Hello everyone. Uh, let's discuss the first problem of the debt-free contest. The problem says little Royce has a phone, or maybe I can just explain here. Okay, so it says that there is a phone which is having dimension as 5 into 3. Here, by 5 into 3, I mean that there are 5 rows and 3 columns. So there are these 15 cells basically, right? They have actually showed the way. So the phone looks like this, and there are two type of widgets. There are okay, so there are two type of applications. The first one is having the icon size 1 into 1, and there are Y applications having the icon size 2 into 2. So the applications having the size 1 into 1 will take up one block, and the applications having the size 2 into 2 will take 4 cells or 4 blocks together. है ना? These four should be in this way only. And we have been like told the number of blocks with 1 into 1 size, and the number of blocks, there are y number of blocks, sorry, y number of applications having the size 2 into 2. Okay. Somehow it got open. And all we need to do here is just tell how many screens will be required. So how many screens are required here? And we want to tell the minimum number of screens which would be required. So is the problem clear? Let me take one example. 7, 2 maybe. If you have to place 7 applications of 1 into 1 size and 2 applications of 2 into 2 size, you can do it some in a way like this maybe. This is 2 into 2 and another 2 into 2. Sorry for this, like one of them is looking big and the other one is looking small, but let's say that both of these are having 2 into 2 size, and then okay, I should have a good track, right? uh, five. Let's say that this is the mobile grid, then you can just place one of the 2 into 2 applications like this and the other one like this, and for the rest of the applications with 1 into 1 size, you can put them at these places. So we will be able to place all of these 7 1 into 1 blocks and 2 2 into 2 applications in one screen only. Firstly, I calculated triplets first, then thought one screen can have at most. Okay. Okay, so I am assuming that the problem is clear since nobody said no. So here, the very first observation I had was the exact same observation which someone has actually mentioned in the chat, that in one screen you can have at most 2 blocks, or maybe you can just say it as 2 applications of size 2 into 2, right? Can you see my pointer if I'm moving it? Can you see it? When I'm writing something, can you see my pointer? First of all, I should have it built up. I don't know why, but some setting has been changed automatically. When in the evening I took the class, it was fine, but now it's not fine. Okay, so like this was the first observation I had. I just got it almost instantly. And as soon as I noticed this, I just realized that you really need to put up all those Y 2 into 2 2 applications first. the Y applications with this 2 into 2 dimensions. And once you place all of them, after that, in every screen, you will have, in all the screens where you placed two blocks of 2 into 2 dimensions, there you will have like seven positions where you can place the 1 into 1 block. And in the last screen, let's say that if Y is odd, then you might just have 1 2 into 2 block at the end. Then in that screen, you will have 11 spaces left for this 1 into 1 uh, applications. So this was my idea there, that if I'm having maybe Y number of applications of size 2 into 2, then I will definitely require at least this many screens. I will require at least this many screens, which is obvious. And after that, in these screens, I will have a lot of free spaces where I can just put up these 1 into 1 blocks. So let's keep it simple. Since this is the A problem, let's keep it very simple. This Y will either be even or it will be odd. And let's say that if it is even, it is a very simple case. You will have Y by 2 screens. You will have exactly Y by 2 screens where you will just place all those 2 by 2 blocks. After that, in all these Y by 2 screens, you will have 7 spaces left. So you can just place 7 into Y by 2 number of, like you will have this many free spaces for placing those 1 into 1 blocks. So let's call this thing as free space. So from this free space variable, you can just subtract, or maybe like you have this much space now. So in case if this free space is greater than or equal to x, then this Y by 2 is your answer. Otherwise, in case if x is greater than this free space, then you will require x minus free space. You will require this many more blocks, and in every page or in every screen, you will be getting 15 uh, slots, or maybe 15 blocks, or whatever word they use there. They use the word like, okay, 15 cells. You will be getting 15 cells, right? So all you will need to do is just say that if this value is, let's say, x dash, then you will require x dash by 15 seal division. This many uh, more screens, right? Guys, does it make sense? Does it make sense that how you will solve the problem for y being even? Or does anybody have any doubt here? For the case when y is odd, it is pretty much similar, because you will require this many complete screens. Like uh, you can just assume it as you, like you know how to solve the problem for y being even. So you can just say that for y minus 1 applications, you can do the exact same thing which you were doing earlier, like at least till this place, that you will require this many screens, and you will require one more screen where you will place the last application. So you will indeed require y minus 1 by 2 number of, okay, so I can just call it as y plus 1 by 2 actually. Like earlier, I was writing it as y minus 1 by 2 plus 1. So you will require this many screens. In the y minus 1 by 2 screens, you will have 7 spaces left, or 7 slots left. And in the last screen, you will have 11 cells left. So again, you can just do the exact same thing. You are having the number of free spaces or free cells. So you will just compare it with x, and depending upon the value of x, in case if x is greater, then you will find out this value, and this will be the extra number of screens you will still have to go with. So I hope that it makes sense. So the solution will be, I can just show the code instead. So the solution is like this for each and every test case. First of all, okay, like in the explanation, I took up these cases differently for even and odd. But if you try, you can actually write a code where you can just combine both of these together. Like you can just say that uh, you will require y plus 1 by 2 this many pages, this many screens. In case if y is even, then y plus 1 by 2 flow division will still give you the same value as y by 2. And in the case of odd, it will give you this amount. And after that, you can find out the number of remaining, actually the free cells you have. And once you get the number of free cells, you can find out the extra number of free cells you require. So x minus the number of free cells you have got. Like I'm just finding out this value, and in case if it is going negative, then I'm just calling it as 0. And after that, I can find out x. Okay, so writing like this is something you can remember, that if you ever have to find out um, a by b seal division, then you can call it as a plus b minus 1 by b in any language like C++, where by default it takes the flow division. Do you get the optimized approach in the first time, or do you change it later? For this problem, I just got it instantly. Okay, so guys, does it make sense? Or does anybody have any doubt regarding this problem? Okay, one of you said no. What about others? Clear? Great. Okay, so let's look at the next problem. The next problem is symmetric encoding. This problem says that Polycarp. Okay, let me tell you about this here. The problem says that you will be having, you will be given a string. Just 1 minute. Yeah. So you will be given a string, let's say like code forces, and on this you will perform an operation. The first thing you have to do in this operation is find out all of these distinct characters. Like just find out all the distinct characters in this word, which is C, O, D, E, F. We have already counted O, so we won't count it again. R, we have already counted C, we have counted E, and this is S. Then write it alphabetically. So it will be something like C, E, no, C, D, E, F, and O, R, S. Now the thing you have to do is wherever you see this character C in the word, like we find it here, just replace this C with S. Wherever you see this C, you just have to replace it with S. So we will say S. Then at the place of O, just figure out where, like in this word, you have nothing to do with this guy anymore. Like you can just forget about it for now. All you will have to do is in this word, wherever you see this C, look at the opposite or the mirror character. Like if you just uh, see this in a mirror, see this word in a mirror, it becomes like SROFEDC, right? In the mirror, it will look something like this. Obviously, in the uh, mirror image will be like this, like you got the idea, right? At the place of the C, you will place this character. So at the place of the first character, you place the last one. At the place of this D, you will place R. So we find this D here. We will place R at this place. We see this E at this, like wherever we see the E, we will place O. So at this place and at this place, we will place O and so on. We will just do the exact same thing for all of these characters. So our string will look, I think I have already told how it would look like. It becomes Sarah, what are they written? Okay. It becomes Sarafat. Okay. It is some weird word. How many problems are we discussing today? We will discuss all the 7 problems today. Okay. So we have been told that a word is encoded in this way. Now we will be given this word and we will have to figure out the word from which it was encoded. Is the problem clear? Okay, great. So the simple idea here is, yeah, here the simple idea is that first of all, the problem is a bit twisted. They have told us how to encode, but they have not told us how to decode. They have not told us anything about it. But the thing is, uh, like whatever characters this string had, this string will also have all of those characters. So this thing will come up the same for both of them. है ना? And when you sort this alphabetically, you will get the exact same string, right? So while encoding, we just replaced all of these characters in this way that wherever you see an E, you will replace it by O, and wherever you see a D, you will replace it by R, and in this way, right? Similarly, for this string, you will get the exact same thing. So if you encode this string, like in the process of encoding, you will get this same string once again, right? Um, if instead of this code forces, if you had this string, you would have got the exact same stuff till this part, and only at the point part of uh, putting up these values, like just replacing them in this way, S, C with S, D with O, no, D with R, and E with O, and F with itself. If you just encode it once again, all of these characters will come back. Wherever you had a C, you got an S in this string. And if you just replace it once again with the character it matches, you will get the original character. So does it make sense that we just have to encode the string for decoding it? We have to just encode it again. Exactly. And now for the part of encoding it, one thing you have to do is figure out this string. And figuring out this string is not really that difficult. You can either use something like just put up all the characters of the string inside a set, and then when you fetch out all those elements from the set, they will be in this order, all the distinct characters in the sorted order. And there are some other ways as well. This is, I think, the most convenient way for you. Secondly, once you put up all these characters inside a vector, all you need to do is you can just create a map. You can do something like map of char with char, and in the map you can just put up something like for this C. Let's say that you have the map name with NP, then you can just say it as NP of C is equal to S, and then you just have to iterate over this string. Like you just have to iterate over the string and map in this way. For this D, the opposite character is R. For E, the opposite character is O, and so on. And once you're done with mapping these characters with each other, after that, just iterate over the string and replace the characters. Similarly, in this way. So I hope that it makes sense. Like for this problem, that's it. That's all you have to do. Now, in case if you don't know about map, I would suggest you to first of all study about it. It is a really useful data structure. You will eventually have to learn about it anyways. So it's a good idea to just study about it right now. Similarly for set, these are not really that difficult. These are just as difficult as vector. If you know about vector, then you can easily learn about set and maps as well. So anybody having any doubt, or shall I move on to the code part? Mm, above query, let me see. Oh, I missed this. Sorry. I have used the map. I don't know why it gives me wrong answer. When I used vector, it worked fine. Um, I think there is some error while hashing. See, you can do it with maps as well. You might have done some syntactical error. After the session, you can show me your code, and I can have a look at it. It would probably be some syntactical error. Using maps is fine, and a lot of people are just saying that they have used maps. In my case, I think that I just overcomplicated the code because I was not willing to use a map or a set. I wanted to do it with simpler stuff and not use these data structures for the B problem. So here is my code. For each and every test case, I have been taking the inputs first. After that, uh, like this process can be done with sets. Here, like this code might look a bit ugly. What I have been doing here is, first of all, I'm putting up all the characters of the string inside a vector. Then I have been sorting the vector so that all the characters come in an alphabetical order. And then I have been using the resize function and the unique function to remove all the duplicates. Now, if you don't know about this syntax, you don't really need to worry about it. You can just, if you just know about sets, you can use it directly. It's fine with it. Using sets is easier, though I think, like, not just think, it's actually generally faster to use. In like this is generally faster than sets. But for the B problem, it would be fine even if you use a set. And after that, I have been using a lower bound function to find out wherever this um, character stri is coming up, and then I have been finding out the other guy. But if you want, you can just first of all create a map and then do some mapping, and uh, in that case, it will be a lot simpler for you to code. During the contest, I was just willing to code in this way, so I coded it up in this way. If you guys ask me in chat, then I can submit the problem with maps and sets as well, so that once you are looking at, like when you are looking at the YouTube video, you can just go into the description and see a code with the maps and sets as well. I was aware about it, so I made another wrong summation during simple map. And if the unordered maps are generally exploited, say prefer to use them. Yeah, you should not use unordered maps. Like generally don't use unordered maps because they can be busted up. Yeah, they can be hacked. If you want to use maps, then you should have just a custom hash or something like that. Okay, so how does that work? I also don't know about it. I have never tried to hack someone's solution with busting up his map. Is this problem clear? Like, shall I move on? My code is actually a bit ugly, so I don't really have a lot to explain here. I'm not really suggesting anyone to code in this way. Um, the main thing was the logic. If you know about the logic, you can just code it up without any problems. Okay, great. Oh, sorry. Okay, so let's look at the third problem. The third problem says that Polycarp was given an array. Okay, so this is the third problem. It says that there is an array of n size. Let's say array A of size n, and for all the triplets aj, aj plus 1, and aj plus 2, right? If you are picking up three elements, it's a triplet. And here we have been talking about the triplets of three adjacent elements. It will be there for all j from 1 till n minus 2. So what we have to do is, for all the triplets, uh, would anyone like to guess how many triplets will there be in the array? How many different triplets are there? Exactly, n minus 2 triplets. So for all of these n minus 2 triplets, we have to find out the number of pairs of triplets which are beautiful, and the condition for them to be beautiful has been mentioned here, that if they differ in exactly one position, if you have something like a triplet b1 b2 b3 and a triplet c1 c2 c3, it will be beautiful if either b1 is not equal to c1 and both the other positions the elements are same, or if b2 is not equal to c2 and at the other positions elements are same, or the same thing for b3. And we have to find out the number of beautiful pairs of triplets among the written triplets. So yeah, this line looks a bit ambiguous, but like this part looks a bit ambiguous, I think. But the main thing is, in general, they have been asking us the beautiful pairs of triplets, or actually the number of beautiful triplets. So um, here is a disclaimer that the problem is a bit difficult. In like generally, the Dev 3C is a lot simpler than this, but in today's contest, we got a bit difficult one for the C position. So let's talk about a simpler case. Let's make the problem a bit simpler. Let's say that a triplet is beautiful if B1 is equal to C1, B2 is equal to C2, and B3 is not equal to C3. Let's say that this is the only possible condition for a triplet to be beautiful. In that case, how will we solve? Now the problem is not that difficult. Just that having three conditions together is making the problem more complex. But right now, I think it is simpler now. Okay, so would anyone like to guess how would you approach this? Okay, somebody said map of this. No, no, no. Wait, we are having some interesting solution, I think. Map 1 AB plus map 2 BC plus map 3 AC minus 3 into map of ABC. Okay, so looks like your solution, I don't know, like if your solution is correct or not. Mine is definitely more complex than yours. And unfortunately, that's the only thing I can discuss right now. So in this kind of a case, what you could have done is, for all the triplets whose first two elements are same, let's create a map in which the key is a pair of integers and the value is a vector of integers. It surely looks complicated. Here, the keys we are having is the first two elements. So every pair of triplets, like for all the triplets where the first two elements are same, they will be having the same key. So in the key, we will just put up B1, comma C1, sorry, B2. Or maybe if we are talking about a triplet of P1, P2, P3, three elements P1, P2, P3, then what we will do for it is we will say that in the map, put up P1, comma P2 as the key, and like this map of P1, P2 will give me the vector, the value for that key is a vector, in which I will just push back the third element. This was my intuition that if I do something like this, the reason I have been doing it like this is because um, let's like in the simpler problem we are talking about, we are having the first two elements equal. So I just want that all the triplets whose first two elements are equal should come up at the same place. So for all the triplets with the first two characters same, they will be there. Now I will have like for this pair of two elements, I will be having the a vector for all the triplets. The third values might differ, might be same. So let me just take an example. If you are having something like 223, 224. So this is one triplet, this is another triplet where we are having the first two characters is 2, 2. Right. So in the map of 2, comma 2, you will be having 3 because 3 was the third character in one of the triplets, and in another triplet you were having 4 as the third element. Right. Now the problem just becomes equal to, like for this vector, the problem becomes equal to finding out the number of pairs where both characters are different. Now for this vector, all you need to do is just find number of pairs of different characters, which is a lot simple, like a lot simpler. So, guys, tell me in chat that does this thing make sense? How we are making the problem simpler? First of all, what we did is the problem looked complicated, so we made it simple by just eliminating the other two conditions and talking about only one at a time. Now, from that one condition, we try to make the problem simpler that for all the triplets where the first two characters will be same, I will take care of all of those triplets together, and then I will just do the exact same thing for all the other pairs of triplets as well, like for all the triplets, other triplets as well. So now once I pair up all the triplets together whose first two elements are same, I will get a vector of elements, something like this. Now, in that vector of elements, I will just have to find out the number of pairs of different elements, basically, different values. The number of pairs of different values. Okay, so the chat says map. Okay, Soumya, exactly. I solved using two loops, but for TLE. Yeah, two loops won't work. Need the constraints. The constraints are pretty huge and will be like less than equal to 2 raised to the power 2 into 10 raised to the power 5. So n square will definitely fail. And but why your solution is more complex than us? The reason is that during the contest, this was the first thing I got in mind, and since it is not really that difficult to implement, I just implemented it right away. To explain it is a bit difficult because there are a lot of things, and like in case if I don't explain it properly, then it will be very complicated. And I think that it will still be complicated even if I explain it properly. It will be more clear once you try to implement it after the session by yourself. At that point of time, you can take help from the editorial. Okay, so or pair of int would also work. Pair. What is this pair of int? Like, okay, so are you asking that have a pair at this place and have an int there? So we need to make three maps, right? Yeah, exactly. If you know how to solve the problem for this type, you already know how to solve the problem for the other types as well. Because the only difference there will be instead of having these two as equals, you will have these two as equals and this one as different. I know. So you will just have to repeat the process three times. Now that is something like not really recommend it when you are practicing, but during contest it is fine if you just write repetitive code because you need speed during the contest. But what are we comparing to? Another triplet. There are four siblings. How do you find the number of pairs as there may be reception in vector? Repetition in correct. Yeah, there can be repetitions in the vector. See, if you are having maybe a triplet 2 comma 2 comma 4 and a triplet 3 like maybe let's have it as 2 comma 2 comma 3 and a triplet as 2 comma 2 comma 5 and a triplet as 2 comma 2 comma 3 maybe. Then finding out the number of triplets who satisfy all the three conditions is actually equivalent to saying that first of all you are finding out all the triplet pair or like all the triplets where the first two conditions are met, that these people are equal and these people are equal, and for the third condition you are actually delegating this task that first of all you are just storing up all the values inside a vector and then you say that now tell me the number of pairs of the number of pairs among these elements where the uh, values are different, right? So this will have something like this 4 is different from three people, this 4 is different from three people, so plus 3 for this 4. This 3 is different from this 4 and this 5, but we have already counted that it's difference from 4, so we will not count it again and we will just say that 3 is different from 5, so plus 1. For this 5, it has like it is different from all the other three people, but we have already counted the pair 4 comma 5 and the pair 3 comma 5, so we will only count this pair and it will have a plus 1. And for the third guy, we will have nothing. So it will have five pairs. So we need three maps. Yep, we need three maps. And I think that there might be some simpler solution. The intended solution should be simpler, as somebody wrote in chat. Um, I saw a few other people's code, and I felt that their code was also difficult. So maybe a simpler solution might not exist. I don't know about it. So we need to use two for loops for calculating pairs. Um, if you want, you can actually have two for loops here. It will give you a TLE. The a more optimal thing which you can do here is just find out the frequencies of all the characters. Maybe use a map of int comma int here for keeping track of the frequencies of all the elements in this vector, like specifically for this vector, and it will make things easier for you. Like using a map will help you to do this work in big of n log n time, where n is the size of this vector. Okay, somebody has pasted his code, but unfortunately I can't understand the code right now in the Zoom chat since the syntax is not maintained in here. Na? Okay, so anybody having any doubt in this approach, or should we move on? Like, by move on, I mean that talk about the rest of the logic for this problem. We have not completed the approach completely. Okay, great. No doubts. Okay. Okay, so we did the problem till the part of, we did the problem till this point that we will have to figure out the number of different pairs in the vector. Now, this is a standard problem. Probably you will be able to find out it on internet if you search something like find the number of pairs or the count of pairs with the different values maybe. And like it's something simple even if you don't find the problem online. If you have something like 1 comma 1 comma 2 2 3 4 5 and you want to find out the number of different pairs here, what you can do is just iterate over it once, and while iterate over it once and calculate the frequencies of all the characters. So one is coming up two number of times, two is coming up two number of times, three is coming up one time, four is coming up one time, and five is coming up one time. And what I generally prefer in this kind of a problem is for like again, once you calculate this, just iterate over this array once again. And now for each and every character, you know the number of times this exact same character is coming up in the array. So if one is coming up twice in the array and the array size is 7, then you know that 7 minus 2, there are this many characters which are not equal to 1. Similarly, for this other one as well, there will be 7 minus 2 number of characters. For this 2, its frequency is also equal to 2 and there are total 7 characters. So there will be 7 minus 2 characters and so on. And in this way, we are actually calculating this 1 comma 2 pair twice. Once when we were at this place and once when we were at this place. So at the end of the day, once you figure out the complete, like the number of different pairs of different elements, let's say it is answer, then you can just divide it by 2. 7 in 2 where uh, Kevin, I'm not able to understand what are you asking here. Can you just please write it again, maybe a more elaborative question? And what about others? Do you people have any doubt till this point? And like the rest of the part is really simple. If you know how to figure out the number of like the number of pairs of different elements for this vector, for a vector, you just have to do this same thing for all the pairs, for all the possible pairs, which is not a difficult thing. And you will have to do this for the other combinations as well. Like right now, we have talked about only one combination, that is this one. There are two more combinations. The logic is exactly the same. You will just have some differences in implementation. The code will get a bit longer. And at the end of the day, you will just have to print the answer. And the answer, um, I think it will be good to just have long as the data type to make sure that you don't get any wrong answer by mistake. Um, suppose index is 2. Here it is 2, right? So already 2 is counted and its frequency is 2. So we can take the size which is 7 minus index minus frequency. Yeah, you can do it in that way as well. So like when you were talking about this 2, you could have absolutely done something like, just one second. Yeah, you could have absolutely done something like this, that this is the number of like elements you have left coming up after this 2, and this is the number of times 2 is coming up in the array, so you will get the number of different elements. You can think in that way as well. Yeah. One more way in which someone could have thought about is just iterating over it once. Whenever you come up over any character, increment its frequency in the map, and like at every position, you will just know about the number of different characters on the LHS you have seen so far. So you will have to iterate over only once, iterate over the vector only once. So now let me show you my code. The code is really ugly. I will not even lie, the code is really ugly. Uh, or maybe actually less uglier than others. Other people actually had even uglier code. So what I did here is I created a vector of these maps. You saw this kind of a map here. The map of pair of integers have as the key and vector of integers as the value. Instead of having pair of integers as the key, I have an array int 2 as the key. So it will just have an array of size 2 as the key, so that for accessing the elements of the array, I will be able to use subscripts like 0, 1 instead of writing first and second, which we have to do in pair of integers. So like both of these are fine. If you want, you can use a pair of integers. It's the same thing. And since I had to create three different maps, I created them inside a vector so that I will not have to write this code three times. Instead, I am just using a for loop here. And uh, this is what we were doing earlier for one map. Now, since I'm having three maps, I will have to specify the map I'm talking about. And the statement is almost simple, like simple, not simple, but similar. And similarly for the other two cases as well. And after that, I'm having a variable with name answer, and I'm iterating over all the three maps. Yeah, actually, I wait. So okay, so I'm iterating over the three maps. For each and every map, I'm going over all the key value pairs basically for all the pair of the two equal elements. And this V will have all the different elements. So sorting was not necessary. Okay, sorting was not necessary. Like earlier, I was not willing to use a map. I was just willing to use do it with some other way, maybe something like a binary and uh, upper bound and lower bound functions. But then I felt that it will just lengthen my code, and then I decided to use a map. So ignore this line. Will sorting give you TLE? No, 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 no. Even if you look at it, this part of the code is already having big O of n log n time. Sorting also takes big O of n log n time, and generally sorting is faster than these maps. The map looks like it is also taking log n time per complex per operation, but it has a lot of constant factor as well. So this sorting is having negligible uh, difference in time. So I used two for loops here, and that's me being very stupid because it was not really necessary to use two for loops. It could have been done with just one for loop, um, but it's fine. Yeah. So there is this one thing, creating a vector of this, like something, even if we are having something complicated, creating a vector of that so that you don't have to write this thing three times. Instead, we are able to write it only once inside a for loop. This is something you can practice from this problem. It like generally saves a lot of times, because let's say I wrote some code and then it is not working, and while debugging, if I have to write some print statements or If I have to comment something, uncomment something, make some changes, I will not have to do it three times or at three different places. I will have to do it at just one place, right? So this is something you should definitely try. Okay, so let's move on to the fourth problem. The fourth problem, ingenuity 2. Was there was ingenuity 1? No. Okay, so in this problem, it says, mm, I will just tell you about the problem statement with a little different meaning. Everything will be same. It's just the story will be a bit different. Let's say that Alice and Bob are playing a game where both of these people are at um, the coordinates 0 comma 0, and you will be told some series of moves, maybe right, up, down, left, some combination of these moves, something like this. Okay, sorry, not right down, but actually north, south in that way. So you will be given something like north, south, east, west. Or maybe just write it as news. You will be given some directions in this way. So what you will have to do is you will have to say either Alice will move or Bob will move. For each and every move, exactly exactly one of them will move in that direction. So initially, when Alice and Bob are both at the 0 comma 0 index coordinate, let's say that the move order is WESN, WES and N. Then for W, someone like one of these people will have to go towards the west. Now let's say you chose Alice to go towards the west. Then for east, maybe let's say that we chose Alice to come back to the east. Then for south, you will have to choose one of these people to move. Maybe let's say that we said Bob will go to the south, and then for the north step, Bob will come back. You can decide which person will move where, like which person will move on this step. And what you want is after all of these n moves, both the people should be at the same coordinates. Should be at the same coordinates. So this is first condition. And there is one more condition that both of the players must move at least once. Both people must move at least once. Okay, so these are the two conditions. And what we will have to do is something like for WESN. Right now we talked about Alice and Bob. The problem statement given actually had something like um, I think rover and helicopter. Yep, rover and helicopter. So I don't know what is meant by rover, but whatever it is, for each and every move, you will have to tell either R or H. So if you say something like R or H, it means that rover will first move towards the like this move will be performed by rover. This would also be performed by rover. This will be performed by helicopter, and this as well by helicopter. So we will have to give the answer in this way. So just please confirm whether the problem statement is clear or not. What is the difficulty rating of D? Um, I think D is simple. Generally, D is supposed to be around 13, 1400, maybe at least 1200. And it should be around this only. Someone wrote 1409 in chat. And it can very well be equal to 1409. So the intuition which I had when I read this problem was if there are odd number of moves, if there are odd number of moves, then it is never possible to um decide the moves for both the players and have both the players ending up at the same place. Let me take one example. Let's say if you have north, south, north, north, north. Now, whatever you do, eventually, um, like for the initial coordinate, the coordinates are 0, comma 0, and the sum of the coordinates is even. When you move in any one of the directions, like whenever you make a move, you will reach a coordinate whose, let's say, if you reach to this coordinate, which is 1, comma 0, it will be odd. It's the sum of its coordinates will be odd. है ना? And whenever you move from this to to any of the directions, its sum of coordinates will again become even. So, like if the total number of moves for both the players is odd, it means that one of the players must move odd number of times and the other player must move even number of times. Right. And if a player is moving odd number of times, it's like at any place it um, ends up at the end, the sum of its coordinates will also be odd. है ना? Sum of coordinates will also be odd. And for the person who moved even number of times, the sum of its coordinates will be even. And we know like this is good enough for us to be satisfied that if one of the people is having odd number of like odd as the sum of its coordinates and the other one is having even, then it means that both of these people can never be equal in any case. है ना? It does not depend upon the move sets or anything. It's directly no. So did it make sense? Is it clear? Guys, please write in chat. I'm waiting. So sum of n plus s should be even. What is s here? What do you mean by s and what do you mean by n? North south. Yep. The number of north plus south moves. Like right now, we have not really proved it. Right now, the proof we have given, this proof we have given, is for the total number of moves. That if the total number of moves for both the players is n, like if this n is odd, then we can right away say that the answer is not possible. And similarly, we can actually prove for both the dimensions as well. It would be even simpler in case of one dimensions that the number of moves you play towards the left and towards the right, basically east and west. So the count of east plus the count of moves for west, this thing should also be even. Similarly for south and north. It can be proved in the exact same way we proved here. And like here the proof proof is even simpler because you have only two directions, either go left or right. So you know that if you add plus one or subtract one from any number, its parity will change. So we have figured out that the answer will be no if either for the um, east west or for the north south, the sum of those moves is even. Then it's fine. If it is odd, then the answer will be just no directly. Now talking about the case where we are having some moves like maybe NEWS. By the way, there was one more edge case, something like NS. If you are having only two moves, north and south. So uh, if you have like if you choose them in this way that one of the people go towards the north and the other one goes towards the south, then you will not be able to satisfy the condition of both of the people ending at the same place. And if you say that one of the people go towards the north and then comes towards the south, then you will be able to fulfill the condition of both the people ending at the same place, but you will not be able to fulfill the condition of both the players making at least one move. So if you're having only two moves, it is never possible. And like for this kind of a case, obviously it is possible if both the moves are same. If both the moves are same, then you can just have both the people going up towards the north one by one. But if you're having something like NS or SN or EW or WE, in these four cases, it will not be possible. And obviously, in the cases like ES, it's definitely not possible if you are moving 1% towards the south, and 1% towards the east. And indeed, we would have already pruned our like inputs that if we are having this kind of an input where for any of the dimensions the number of moves are odd, then we would have already removed that kind of a pair. So, are you guys with me till now? Great. Now the remaining solution is actually pretty simple. All you need to do now is just imagine that you're having the moves towards east 8 times and the moves towards the west 4 times. And you want that both the people should stay on the same uh, point at the end of the day. है ना? So you know that like eventually both the people will be moving two steps towards the east. Basically, what I want to say is this 2 comma 0 should be the ending point, right? Because you have to play 8 moves towards the east and only 4 moves towards the west. So for both of the people, there are two extra moves towards the east, and you will like to distribute them equally among the two people so that both of these people end up at the same place. I hope it makes sense. Great. So what I did for this is like when we listen about it, it makes really a lot of sense and it looks really simple. That all we need to do here is just divide these moves equally. That both the people can move 4 times towards the right and 2 times towards the left, and similarly the other person can do the same. But you might have something different. You might have something like E is coming up 5 number of times and W is coming up 3 number of times. You might not be able to divide them that easily. So you will have to think of a different way for distributing these steps. What I did here is I just said that you know that there are two extra E's. So one of like both the people will have to perform one extra E operation, है ना? One extra E operation in comparison to the west operation. So why not just have one person go only one time towards the right and the other person having all the west operations and the remaining E operations. I just had in this way that like I have to perform east operation 5 times and west operation 3 times on both the people. So first guy and this is the second guy. What I did is one of the people will just move one step towards the east and the other person will move 4 times towards east and 3 times towards west. You can just verify it that it completely makes sense for all the um, like this 5 e's could have been written as 2 extra e plus 3 e's which can be combined with the 3 wests. So these moves can be cancelled out with each other. So I'm just using the second guy to play all the moves, and for the first guy, I'm just playing the one of the extra moves. So that like my implementation will be really simple. This is something optional. If you want, you can have a different way of implementing it. Like let me just mention it for the YouTube audience. This is opinionated thing. You might have a different style for of thinking. So you might like to do distribute it in a different way. So I would say that don't comment and ask me that why did you distribute in this only. You can distribute in any way. And there was one edge case which I was facing. Oh yeah, before the edge case, till this point, it seems like we have almost solved the problem. The way in which we were dealing with east and west, we just have to deal with the north and south in the exact same way. So the problem is almost done. Now the only thing you will have to worry about is what if you are having something like um, east, west. In this kind of a case, there are no extra east and there are no extra wests. By the way, if earlier you were having maybe seven number of wests, if the number of wests were more than easts, then the only difference would have been that you would have considered first guy moving towards west more one more time than east. Like you got the idea that it would almost be the same thing. And similarly for north and south it would be the same thing almost. Now for the last place, this is an edge case which I missed earlier, but in the sample test cases, I was able to see that my code was actually giving a wrong answer at some place. Like it was having incorrect answer. So uh, this sample test case actually saved me from a penalty. Otherwise, I would have submitted the solution and then I would have got the penalty. But due to this, I got saved. So here in this kind of a case, what will happen is the first guy will not move and second guy will just have all the moves of going east, west, and east, west. And these people will um, end up at the position 0,0. This is something we don't want. We want that both the people should be having at least one move. So in case if the count of east and west is same, then I said that hey, just let this first guy move once east and west, just once, like one time east and west, and for all the other moves, the second guy can have it. This is just um, I just removed that edge case. So it's up to you in which way you would like to remove the edge case. This is again opinionated thing. Okay, you failed to figure out this edge case. Okay, it would have been said then. Okay, I think that the problem is done. Now you just need to implement it. For implementation purpose, let me show you my code. And I can't really help much regarding the implementation. This is not a standard thing, and um, it does not even have anything which I can teach. This is a very ad hoc problem, very ad hoc. So it has nothing to do with mindset. Um, so like in my code, what I've done is I've created a function with name solve, which will return a string, and I will just print that string. So in case if the string is any one of these four edge cases, in that case, I'm right away printing no, and you can remove this dbg line. And after that, I created an answer variable, an answer string, which is initially having all the question marks. And this is a function. This is a variable I created as have got for this case, that has the first guy got any move yet or no. So for that, I created the variable have got. And since I had to do the exact same thing for east, west, and for the north, south, I created a function in which I just told about the uh, character towards the positive side and the character towards the negative side. So, like this negative is in the sense of this. I considered north and east as positive x's and the other ones as negative. Obviously, these are just some stupid names. You can have better names here. Here, I'm calculating the number of counting the number of times um, this east west or north south pair is coming up. So whenever I see a east guy, then I increment the total count, and in the other case, I just decrement the total count. And in case if the total is um, odd, then we know that we have to print no. So for this, what I've done is I just printed, like I just returned a boolean from this function, and at the place where I called this function, I wrote it in a way that in case if the function fails, then I will return no. And then I'm having the case for handling that what if west is coming up more than east or if south is coming up more than north. And after that, I'm just keeping track of the number of times I have to print the person with like the direction which is coming up more number of times. Then I'm going on to each and every character, and there are some if else conditions like first of all, if the current character is neither the positive guy or the negative guy, then just skip. Otherwise, in case if it is um, the direction which is coming up more number of times, and the target, like target is the number of times I have to choose that. If it is positive, then I will just print answer and reduce the value of target. Otherwise, I will just put a helicopter there. And then this is the edge case, that in case if you have not got any character yet and the total count is zero, then I'm just finding out the first occurrence of plus and the first occurrence of negative, and I have been updating the values there as RR. That's it. So the implementation is actually more difficult than the C problem. But the reason I called C problem to be harder is because for the C problem, I think that it is supposed to be simpler than a lot simpler than this, than what we got in the C problem. And I think for D problem, it is okay. D problem is generally like this only. Here, the implementation is a bit long, but the problem is simple. Okay, so shall we move on to the fifth problem? Mm, yeah. Okay, so the fifth problem is money buys happiness. Oh wow, they gave a really good name. How many problems will we discuss? We will discuss all the seven problems. Obviously, for the later problems, like in the earlier problems, I explained very deeply, but in the later on problems, I will just explain like an overview, because the people who are up solving the sixth or fifth problem are generally very good on their own. Okay, so this is the fifth problem. It says that okay, so the problem name is really good. Money buys happiness. They came up with a really good name. So the problem says that there is a person who has a salary of X rupees or X pounds. Pounds is the currency in I think UK or I'm not sure about the country. It has X pounds per month. UK. Okay, it's UK only. Great. So this is the salary, and what the person can do is for every month we have been told that by spending CI pounds of money, he can buy HI pounds. Sorry, HI happiness. We can get this much happiness by spending this much amount of money in the ith month, and the person cannot go in loss or cannot borrow money. So if a person is having 10 rupees, he cannot buy something worth 12 rupees. He can buy only as much, uh, anything of worth only that as much as the money he has, and he gets money at the end of the month. So if you talk about the first month, like before the first month, he is having 0 rupees. In the first month, he cannot buy anything worth even 1 rupee because he is not having any rupees. He will get X rupees at the end of the month, and like not rupees but pounds. But in the explanation, I think I will just use the word rupees for now. So we have to tell what is the maximum happiness he can buy. Max happiness which he can buy. So at the very least, one thing looks really intuitive here, that like for every month we have only two choices. We have only two choices: either buy happiness or don't. So either spend CI rupees to get HI happiness or do nothing. है ना? This thing is possible only when you have that much money already. So it is coming up with a condition basically. So dynamic programming looks really intuitive here, right? Dynamic programming looks intuitive. It is looking similar to an abstract problem. Exactly. If you try to think about dynamic programming, the a very intuitive thing which will come up to your mind is that for each and every month there are m months, and for each and every month you just need to keep track of the money you have. But the money you have can be very huge, like the amount can be very huge. In general, you are having 1E8 rupees coming up every month. So in 50 months, you can have something like 5E9. So creating a DP array this big is impossible for us. I know. Okay, somebody is saying that maybe use math. But the problem is that there are literally too many states. Even if you use a map, you will have a lot of states which will be reached. So since the states are too many, like since there are too many states, it will definitely give you a TLE even with map. And with vectors, it will not even give you a TLE. It will right away give you MLE because you can't even declare that much memory, right? And as a spoiler, I would like to tell you that at Coder DP contest, if you don't know about it, just search about it on internet. This is a really good resource. It has 26 problems. The problems later on get really difficult, but I would suggest you to solve at least 13, 14 problems. And around the position fourth, fifth, there is a problem with the name knapsack 2. And actually, this problem is just based on that idea. Knapsack 2 is having that idea. So basically, you can just say that you have got a standard problem in the contest. It's an educational contest, kind of like kind of an educational contest. Since the problem is already available on internet, if you are willing to give a try, you can right away just go to this problem. First of all, try it out. And what are educational contests? Actually, the contests in which the problems are actually designed in the with the motive that when you give the contest, you will learn something new. So I think that education contests are supposed to be in that way, though it comes to be a bit different, I think. Uh, so, like my suggestion for now is for the people who have been watching on YouTube, please go to this contest, not just for this problem. I would suggest you to solve at least 13, 14 problems, but at least before attempting this problem, solve this one. You might not be able to solve it on your own. There are lots of resources available on internet who have covered these problems. And Love is one of the people who have covered this problem, and other one is Eric Tom. He has covered all the problems of the contest. So you can watch anyone's solution in case if you get stuck. So for now, I am assuming that anyone who will be listening to the rest of the part would have already solved the problem. And to them, the way in which like I got the intuition is dynamic programming looked intuitive because there were only two steps at every position, and greedy does not look to be worthy here. Like it does not look to be uh, it does not look like the problem is solvable with greedy. So that's why what we get in our mind is that maybe we can try out all the possible combinations, for which dynamic programming is a really good thing. And we were not able to do it with dynamic programming in the normal way, but instead there is a different thing which we could have done. We could have created a DP state as DPM, and the point to notice here is, why is this HI so small? Why is it so small? Like X is very huge, this CI is very huge, but HI is small. And not just this much. We have even been told that for all I over all the test cases, it will be less than equal to 10 raised to the power 5. So there must be something to do with HI. No, there must be something to do with HI. And in this problem, all we have, like, if you have solved the problem which I have mentioned here, you will feel it to be very intuitive, even without the tutorial, that the other second, like, we could have created state as DPM and maybe H, where this state denotes that among the first M, basically you can just call it as answer for one, maybe not answer, but minimum cost for months 1 to M, and getting happiness as H. Okay, so I think that I have not defined it good here. I think that it is not looking good. So like what I want to say here is that instead of keeping track of the count, instead of keeping track of the cost, like in general, there are three things. You would like to know about the months which have passed, the cost which you have spent, and the happiness you have got. Right. These are the three main things. So generally, we are habitual of creating this kind of states that you are having um, m months have passed and this much cost has been used. Then what is the maximum happiness you could get? है ना? But here in this case, the cost can be very huge. So we would like to have the state in this way that m months have passed and you have got this much happiness. So what is the minimum cost you will have to spend to get to this amount? Now in this case, you know that in every test case, m can be at most 50, and this thing will overall be less than equal to 1e5, I guess. Yep, it will be less than equal to 1e5 overall. So the total number of states you will be getting is gonna be just 5e6, which is decent. And the transitions are just big of one time. Like transitions will take only big of one time because um, you are having only two things. Either don't do anything, or like either don't do anything, or the other thing you can do is buy some happiness. है ना? So for the month I, for ith month, if you buy the happiness, then you will go to the DP state, DP of m plus 1, or I would like to write the transition here. DP of m comma h can be either equal to dp of m minus 1 h, like it will be the minimum one of either this or dp of m minus 1, and let's call it as hp, the happiness as hp minus h of I, the happiness of the ith month. है ना? And along with this, the cost will be c of I. So this is gonna be the transition, and I think it's not really that difficult to understand. In my code, you will see that I have written it in a different way. This is known as pull DP here. I will obviously I cannot explain everything here in the video. You can search about pull DP and push DP on internet if you find any resources there. Probably will find some blogs, I guess. So in my code, you will see the push DP thing. Here, this is pull DP. You can use any one of these, whichever feels more comfortable. Or if you want, you can even write recursive DP. So from here on, I think that many people might just like to use recursive DP. In my case, I have written iterative DP with push, like the transitions being pushed. So first of all, I'm taking the inputs till this place. Then for creating the DP array, you know that this needs to be of size only m, and this thing needs the size uh, like the in any case this thing will never go more than the sum of all the h values. So I just created it with the value sum of hi for all I, basically this thing. So I just calculated this and stored it in a variable and then created a DP array with that state, uh, with that size. And I have created, like I have initialized the variables with a value np. Np is nothing but the short form of not possible. So this is not a standard thing or a good practice. Maybe I'm not sure about it. This is something just my uh, this is something I just do myself. I don't know if other people do in the same way or not. This is the base case that for zero happiness there is zero cost, and I have space optimized it. If you can just see that instead of having two-dimensional DP, I'm having one-dimensional DP array. So again, like I can't teach you this thing here. You must have seen it somewhere else, maybe on Take You Forward. Like Striver has created a really good DP series, so you can check him out if you want. From there, I had heard about the space optimization. So this is space optimization DP, and for each and every transition, I'm just checking that whether the state is reachable or not. If the state is reachable, then this is the transition. I know that my code will be looking a bit complicated to most of you. You don't really need to worry about my code. You can just uh, write the recursive code simply, and probably you will find a lot of solutions of other people in the like who would have written the recursive code. And at the end of the day, I'm just checking that for any I, basically for any happiness, if the state is not having not possible on it, basically if the state is reachable, then this will be my answer. So I hope that this E problem made some sense. I know that I did not discuss much in this problem. Most of the content has to be done by you only. I can't help in this. And like obviously, even if I just spoon feed everything on how did I think about the transitions and all, it won't help you. So this is why I'm keeping it on little here. So guys, do you have any doubt regarding my approach? Like if there is any doubt, then please mention, else we can go to the next problem. What does DP state means? सेशन काफी लंबा हो जा रहा है. Yeah, the session is going a bit long, I think. Could you explain transition once? Okay, I can explain transition once. What does DB state means? Okay, so here in this case, I think I mentioned it above. In this case, the DP state, acha, you are asking about the code. In the code, like I have just see the transition of the earlier state we were talking about DP of M, HP. Sorry, my internet went out. Okay, so just please confirm the voice is coming good or not. And can you see my screen? Okay, great. So, like in this case, the DP state, DP MHP means that among the months from 1 to M, we have gained the happiness HP. and the value of this DP state will be the minimum cost to do so. In case of the code, when you see DP of J, it means the minimum cost to get the happiness J, and the month is not mentioned in the DP state. So that will be dependent upon the outside, like the iteration at which we are. So, like the DP state in my code is not really that well defined. It is just space optimization thing applied here because the transitions does not depend upon anything like DP of m minus 2 and anything. It only like for DP of m and then something, its value depends only upon the DP of m minus 1 array. You know? So this is how why we can do the space optimization, and I think it's not really necessary. Probably the code will pass even without space optimization. Like it worked in 62 ms right now. So even with space without space optimization, it wouldn't go above 500, I believe. Like 500 is also a very big upper bound I have set. Probably around 150, I think. Um, Great. So shall we move on to the next problem? The transition, oh yeah, the transition which I had to tell you was um, for getting the happiness HP in M months, um, either you can be already this happy on the last month, or you could have been like your happiness could have been equal to HP minus HI, and you would have got this HI happiness by buying happiness with CI coins in the last month. So these are the two possibilities from where you could have come up here to this state. So the answer will be the minimum one of these. Does it make sense, or do like does it is it clear or not? Obviously, it makes sense, but was I good enough to explain? Okay, I don't even have a fan above me now. Well, okay, so this is the sixth problem now. This is a very weird problem. The problem says that there is a very big board. Let's say that there is a very big board which is having dimensions A into B, A rows and B columns, A rows and B columns. And at some of these positions, like we will be given some endpoints, we will be given endpoints where xi comma yi is the ith point. So in this kind of a way, we will be given some indices, sorry, coordinates for some points, and we will be given some queries, or actually not queries, but moves. There are two people, Alice and Bob, playing a game. They will play their moves one by one. When it's any one of like when any one of them is having their move, they will choose a character and they will choose a value of k. So what will happen is like the character, the direction can be one of these four things, either up, down, left, or right. Now let us say if it is up. If Li says that she chooses up and the value of k is 2, then the two rows from the top will be deleted. And all the points which are lying up in one of those cells, they will be given, they will be awarded to Alice. Similarly, Bob will choose some direction and he will choose some value of k, and the game will continue in this way. We have been told that at any point of time, the value of k will be smaller than the total length of that dimension. Basically, if there are 7 rows, then and Alice chooses either up or down, then k will be less than 7. It will never be equal to 7. And similarly for if there are 6 rows, sorry, 6 columns, then in case when Alice or Bob, anyone of chooses left or right, k will be less than 6. So now the thing is, we just have to count the number of points which Alice gets and the number of points which Bob gets. And the problem is indeed really simple. It is just implementation based thing. Um, like what I did here is I just kept track of this line, like what is the topmost row. Initially, the topmost row will be 1. The bottommost row, which will initially be n. The first column, leftmost column, which is initially 1, and the rightmost column, which is initially m. Initially, this will be the case. Now, let's say if Alice says on some move that please remove 2 columns from the right, then the new right, like rightmost column for us will be equal to m minus 2. है ना? Now, when this happens, what you want is all the like all the points which are lying among these columns should be awarded to Alice or Bob, whoever made that move. And after that, those points should not be accessible for any other person. Like if there is a point here and Alice removes these cells and gets this point, and then on some next move Bob deletes these, this point has already been awarded to Alice. This does not exist on the board anymore, so it will not be awarded to Bob now, right? So what I did is, at all the places wherever we have these cells, these points, the thing is we are having only n points, and in the problem we are being told that the sum of n over all the test cases will be less than equal to 2 into 10 raised to the power 5. So I can do one thing. I can just keep track of all the places where the the points are coming, and I can keep them in this kind of a way, sorted order. So what I did is I created a list of points. For each and every point, I had 3 things: its x coordinate, y coordinate, and the value, which was initially 1. And as soon as it gets removed from the board, I will just make it 0, so that in the future I will know that this point has already been removed. So its um, credits will not be given to anyone. Nobody will get any credits for removing it in the future. And I created 2 arrays. One of these arrays contained all the points in the sorted order, like whose x-axis was coming up in this sorted order. Let me take one example actually. Okay, let's take this example. So if we have something like this, so what we can do is I kept track that on this index, like um, in this column, there is this cell and it is having its value 1. In this column, there is this cell having the value 1. And in this cell, in this column, there is this cell having the value 1. Similarly, in this row, there is this cell having the value 1. In this row, there is this cell having the value 1. And similarly for this guy. The point here is, if I keep things in this way, and let's say on the next move, Bob says that remove all the cells in these columns, if I have kept things in the sorted order and maintained in a vector, maybe maintained in a vector, then I can just have two pointers, one on the left and one on the right. And I can simply iterate over the array from right to left and look at its x coordinate. I can obviously easily keep track of the rightmost column number. So if its column number or its coordinate or its x coordinate is more than the rightmost column, it means that this point has been removed now. And just to make sure that I remove one point only once, or I count one point only once, because like there is a chance that these points might have been removed earlier and like this point might have been one of those. So in that case, I would have not been willing to count it again. So just to make sure that I don't count any point more than once, I'm keeping that variable with it, which is either a 1 or a 0. है ना? Initially it is 1, and as soon as the point is being removed, I can make it 0, so that in future it will be easy for me to just like ignore this point. And I think that the problem should be looking quite obvious now, that you can just maintain two vectors. The first vector is having all the points, the x coordinates of all the points in the sorted order, and the other one is having the y coordinates in the sorted order. So the point is, if I ever have to remove the top row, sorry, the top columns, yeah, the top rows, then I will remove those top rows, and then I will just look up for these um, points from one direction to the other direction, and we'll just check the points which have been removed. You know that it won't happen that some points in between are removed when you perform this operation, that remove the rightmost rows. You know that whenever you are removing the rightmost columns, then only the points which are present on the rightmost uh, position in your um, yeah, which is present on the rightmost position of your vector will be removed. And if you want, you can actually use a deck so that you don't have to keep track of, like, you don't have to maintain two pointers. Instead, you will just have a deck, so you will be able to do things like push back or like pop back or pop front, right? So how many of you are with me right now? I think that not too many of you were coming up till this problem. So just I just wanna know how many of you are stuck at this problem. Okay, Mohit came till this. Great. So is this clear? Like, does this thing make sense? The way this optimization was done by me, and obviously there can be some different ways. This is an implementation based problem, so I can't really help much with anything like intuition or something. I All I can do is just tell you about my approach, explain my approach. Um, so I think that's it. Shall we move on to the code? Most of the things in this problem will have to be done by you. This is an implementation based problem. Like the same thing was true for the E problem and for the F problem as well. Both of these have most of the content to be done by you only. I can't help much in these two problems. And G is a trash problem. And the problems before D till D could have been guided by me. So I did the work there. Now the implementation of mine is quite long and it makes sense. Okay, so one thing which I did is for each and every point, I created a struct in this way. And what I did is I like at the time of taking inputs, instead of just creating an array of integers, I created um, an array of references to those points, or just an array which will have pointers to those points. So I'm having memory dynamically allocated here. It's up to you. If you want, you can just have memory being allocated statically, just a static memory allocation. Actually, that also happens dynamically, I think. Yeah, it also happens dynamically. But you could have avoided pointers if you want. Like using pointers was not required here. You would have to pass things by reference in that case. Anyways, I'm having an array being created, which is keeping track of all the points. And here I've put up y comma x because I just wanted to have y coordinate having the vertical positions and x coordinate dealing with the horizontal positions. Like I just wanted to have my x axis here and y axis here. So that is why I kept input as y comma x. In the problem, this was the x axis and this was the y axis. Here I'm just creating two vectors, hori and verti, which are short forms of horizontal and vertical. And this code is doing nothing but it is just keeping one, like it is creating a vector, actually two vectors, which will have the indices of those points. Like in this case, if this is point 1, this is point 2, this is point 3, and I want to know about, maybe let's have, if this was point 1 and this was point 2 and this was point 3, then in that case the hori vector will have 2 1 comma 3, like 2 comma 1 comma 3, because the point 2 is having the smallest x coordinate and the point 3 is having the largest x coordinate and the one is having in between, so it will be coming up like this. So if alias removes elements from the right hand side, I will have to see to remove the elements from here. Otherwise, if I will have to remove elements from here. And I have just done this part, and you can ignore this dbg line. Then I'm having some variables, like a few variables keeping track of the first row, the last row, the rightmost column, the leftmost column, and so on. Then these pointers keeping track of the points which have not been removed so far in the hori and vertical arrays, and this score array is just keeping track of the scores of both Alice and Bob. And then here I am taking the inputs for each and every move, and depending upon whether the move was up, down, left, or right, I'm making some changes. And this is an else condition, just um, to make sure that if some problem occurs, then I will get to know about it. And you can ignore the dbg lines. And after that, I've just written the exact same thing 4 times. Generally, we should not have repetitive code, but during the contest, I was just not having much of, like I was not even having a good idea of how to write this in one, just write it once and use it 4 times. I was feeling that it will become more complicated because there were some differences. Like here I'm having x, here I'm having y. Sometimes I'm having less than sign, sometimes I'm having greater than sign, and there were some changes every time. So I just wrote the thing 4 times. It says that as long as x, like left is less than equal to right, so the elements which have not been removed, the leftmost pointer to the element which has not been removed and the rightmost pointer, um, the left should be less than equal to right. Obviously, it makes sense. And a hori l pointing x, basically the x coordinate of this point. So this thing is referring to this point. So its x coordinate is greater than right. So if the x coordinate of, sorry, this is the second point. So if the x coordinate of this point is greater than, if this thing greater than, I think it should be less. Yeah, I was reading this. Yeah. So if for this point its x coordinate is less than right, let's say if right someday reaches to this place, the right knee left, yeah. If the left place reaches to this place someday, the leftmost column, then in that case this cell has to be removed. So I will say that the score of the person who has made the turn will increase by the value, and the value of that point will become zero. In case if it was already zero, then this line would have not created any difference. And then I'm having the L plus plus line, L plus plus, because this point has been removed, so there is no point of going over it any again anymore. And I'm just doing the exact same thing for the other three cases, removing from right or up from or down. And then at the end I'm deleting all the points which I created dynamically, because we do have to delete them manually, otherwise it will not be deleted from the memory, it will just cause memory leakage. And at the end I'm just printing my score. So uh, did it help, like did this solution help you a little bit to know the place where you are getting stuck or something? Anyone? Mm, Okay, so let's move on to the last problem for today's contest. So this is the seventh problem, and this is the last one. It says that money buys less happiness now. So the value of money has reduced, sadly. The money cannot buy everything now. The problem says that now money can buy less content. Basically, there are a lot of months. If you remember the fifth problem, m was less than equal to 50 there. Now m is actually less than equal to 5 into 10 is the power 10. Sorry, 10 is the power 5. So the value of m has like highly increased, and you can buy happiness in the ith month by the cost ci, and the way we get money is still the same. Every month you will get x rupees per month, and whenever you buy happiness, instead of getting hi happiness, you will get only one happiness now. So this is why we can buy less happiness now. And we have to tell what is the maximum happiness you can buy. So the thing to notice here is, let's say there is an ideal solution somewhere. Maybe there are some months where we should buy happiness. Maybe we should buy happiness in these 5 months, and this is, let's say, the optimal solution. um, and maybe these were the 4 months till now. Let's say that you have solved the problem till this point, and you have got these four as the most optimal points, months where you should buy happiness. And now you got the fifth month where the price for happiness is actually like quite cheap. Let's say that you can buy happiness in maybe uh, ci equal to 5 rupees, and earlier you somewhere bought happiness at the price of 10 rupees. So in any case, does it make sense that you might consider not buying happiness on this day and buying happiness on this way? Does it make sense? Because the cheaper you buy the happiness, the more the chances you have to buy more happiness, right? So you will definitely want to buy happiness at the cheaper prices. So what we can do is, and like another thing is, let's say, uh, let's say you can buy happiness right now. Maybe among the maybe 15 months have passed. You got 15x rupees as the total salary so far, and you have spent maybe 12x rupees out of those. You are having 3x rupees left, and maybe the price of the current month is 2x. Since you can buy happiness
what will be the advantage of not buying? You want to maximize the happiness you can buy. So why don't we just buy happiness? What will happen if we buy? Like, this is sort of a greedy approach. That at the current position where you we are just imagining that what if we have done the best thing we could do till now, and on the next step, if you are having two choices, basically you have, like, your budget right now is greater than or equal to the cost of the current month, then should you buy happiness or not? um one perspective here can be that just buy the happiness, just buy the happiness for this price. In case in future, if you see that there is some cheaper price than the current price, like you are able to get happiness at a cheaper price someday, then in that case you will say that you will just consider that you had never bought the happiness on today's day and you had just bought it a few months later, something like this. That maybe you have bought happiness for 10 rupees here, 5 rupees here, and then you are now buying happiness for maybe um, 2 rupees. Right now you are having a budget of only 1 rupee, so you cannot really buy the happiness for this month for 2 rupees. But one thing you can do is you can just keep track of all the prices for which you had bought the happinesses. Like, here you have bought the happiness two times so far for rupees 5 and 10. Since every time you will get the happiness as exactly one, so it makes sense that you would like to buy the happiness for for as cheap price as possible. So you would like to buy happiness for this price, and the new price you would just try to say that it would be good that if you had never bought the happiness for 10 rupees. So now you can just do it in this way, that consider that you bought happiness at rupees 2 and 5. So, like, just unconsider this, and for the next month, like for the next month, when you consider the amount of money you have and when did you buy the happiness earlier, you will just say that, hey, I bought happiness here and here. I can just consider in this way, and I can forget about this because it was just making things worse for me, है ना? And let's say that on the next day the happiness is for rupees 5, you can just buy it. Whenever you can buy happiness, just buy it, because um, the only worst thing which can happen for you is there might be some cheaper price in future. Maybe at some point of time the happiness might be available for cheaper price. In that case, you can just say that you will consider as if you had never bought happiness on this day and you had bought it only on this day. So I think that this kind of a mindset might be good enough for solving this problem. um, you can use a set or you can use a priority queue. Since we don't really care about all the prices, like you don't really care about all the prices for which you have bought something, you only care about the most expensive one. If at some point of time you say you just want to buy this happiness, you would like to exclude the happiness you bought for the maximum price. So we can just keep use of a priority queue, and uh, all we need to do is just iterate over the array, and here we are greedily deciding that the best thing which we can do is just buy happiness if possible. Like, this is something we have been doing greedily, that if at any point, if you can buy happiness, then just buy it. If budget is greater than equal to cost, then answer plus plus, and budget would obviously get subtracted by cost, and in the priority queue you can just push the cost so that in future you can remove it. And in the other case, that if the budget was less than the cost, so you cannot really buy this happiness today. You could have just compared it. You could have just said that, hey, in case if the budget is less than the PQ dot top guy, obviously you need to check whether the priority queue is empty or not before accessing the priority queue top. But let's say that in case of priority queue is not empty and the top guy is greater than budget, then it will make sense to pop out that guy and push the current budget. Sorry, not the budget. Sorry, not budget. We had to compare the cost. We had to compare the cost. Obviously, like budget has nothing to do, no, do with it. We have to consider costs, not budgets. Like budget is not having anything to do here. And then you can just say it as budget will be increased by this. Okay, before popping out the element, you can just say it at this place itself that the budget will be increased by PQ dot top, PQ dot top there, and budget will be reduced by the cost here. So you just have to do this for each and every month. And does it make sense? I know that I did not really spend a lot of time in developing intuition here. The reason is simple. I am expecting that when someone is coming up a G problem, he is already greater than equal to expert. So generally, you people are good enough to um, understand such things on your own also. And mainly, I just had to develop the intuition for so long on the ABCD problems. Okay, so I see that only three people are in the meet. Um, anyone, any reply? Shall we move on to the code? Just let me show you the code for this problem. The code is pretty small. Here, I'm just first of all taking up all the inputs. And after that, I've been running up the for loop, and the if else conditions you see are exactly the same way as I wrote in the one note, like one note. And then we are adding some with X, and at the end, we are getting the cost. So I think that there is not a lot of content to explain here. So I hope that the video helped you. And in case if you feel that the video helped you, then please consider liking the video or subscribing to the channel. Thank you.